And thank you for joining today's webinar. My name is Jyotish, and today we'll be talking about agent context and how to use skills to better manage the context and to use to your benefit rather than like Jeremy was saying, spending a lot of token and not getting the answers that you're looking for. So I'm sure if you are playing around with LLMs, Claude, you you're hearing about you are playing with skills, but also you're hearing about all these terms, context, and memory and tool calls and all these kind of things. But I just want to, before we dive into skills, I want to step back a little bit and then see give some background so that on the top of the how to do it, why we're doing it is also clear, which is actually very important in terms of like context and context engineering and make the agents run. So first question is, what is context, right? So in my mind, there are two kinds of context that we usually talk about or deal with. One is the LLM context. So LLM context is the limit or the finite amount of information we can send to LLM for each request. Right? So LLMs by definition is stateless, meaning if you're sending one request and it won't remember the previous what you sent in a previous request. Right? So in order for the LLM to understand what you're asking, you need to send some background information, and that's the information. But the thing is, LLM context is finite and it has a very hard limit. So usually you probably hear about Claude Opus, for example, 1 million contexts. Some models at first, when they first came out, it was like very limited, 128K. And all these contexts, when you talk about these numbers, these are measured in token. Right? So what is a token count? So token count, you can think of token count as when we're sending this information to LLM, LLM doesn't process it as text. So it kind of breaks it down into smaller chunks and pieces, right? So every word might be translated to one token or might be multiple tokens. So just to get a rough idea, let's say if you are dealing with a model with 1 million contexts, how much information you can send, you can just do like a guesstimate for each 100 word, it will consume about like between, let's say 130, 150 token, right? So in a way, it's a lot, but even then, as we go along, in the webinar, it will be very clear like why the context needs to be managed very carefully. But at the end of the day, LLM context is a window or the amount of information you can pass to the LLM and in single request. And it's limited and it's finite. Versus the agent context. Agent context is, so you have an agent which is interacting with the LLM. The agent is doing a lot of things. He's solving a domain problem. He's solving a complex problem. So it needs a lot of information. As the agents are like getting more complex, like doing very involved work, that means it has information about your, all the conversation history and the memory, the things it has remembered across the conversations, some like organizational facts, like skills, like some documents that you have indexed. So that means like all these informations are relevant for the problem at hand, and the agent has access to it. Doesn't necessarily mean that is going to send that information to LLM, but that's basically the context that agent has. So, and it grows. The agent context is something is unbounded, meaning as the time goes, it's keep collecting more and more ambient information, and agent context is compared to LLM context is huge. So that's where basically the problem comes in, right? So I'll go back to the slide. So here the bottleneck is the agent context is unlimited, unbounded, right? You have all these information that agent has access to. But when it comes to sending information to LLM, we are limited, right? So the responsibility of the agent or the agent harness is every time it's going to make a call to LLM, it needs to carefully assemble what context or what information from all this available information needs to send to the LLM at that particular point of time. So that's basically the core of the problem, right? So the context engineering that we say is the LLM or designing the agent in a way that it can pick the right information at the right time and send it to the LLM so that LLM can give information or response that will decide what to do next. Okay? So you might ask, okay, you said LLM context is 1 million token. 1 million token, if 100 word is 150 token, that means like we have a huge amount of information that we can actually send to the LLM, which is true. It's almost 1 million token roughly translates to actually like 750,000 word. That means like it's a couple of books. But even though we have the ability to send all this information, the LLM is actually cannot process all this information, even if you send, all these token, the full token length, right? So longer context is not actually better, right? Meaning the way this LLM work is on the architecture, the transform architecture, right? So each token that you send, it has to attend or it has to look into all the other tokens that you are sending, right? So if you're sending a sentence with 100 words and it has like, let's say 150 token, each token needs to look into all the 149 token and kind of find the meaning of itself in the bigger context. That means if you're sending 1 million token, each token needs to look into 1 million minus one token, right? So there's like a lot of connections going on. So of course, like if it's kind of like comparing with the human, right? If you have to pay attention to a lot of things, you won't be able to like, pay the, equal amount of attention to all this information. So human mind also process information in better in like smaller chunks. So similar kind of things. As more context, the attention mechanism attention degrades, right? So usually like it's found that if you send too much information, LLM tends to ignore what you have sent in the middle, and it will pay attention. It will consider the information you have sent in the beginning or at the end, but it will kind of like ignore the information you are sending in the middle. So your response degraded. You have sent way too many tokens. That means your cost is high, and you actually haven't even gotten the response that you needed in the first place by sending all these token and spending all this money, right? So that's why it's very important to minimize how much token you are sending to the LLM, and that's basically the focal point of all this agent and agentic engineering and all these things is how to minimize and optimize token usage when the agents are solving a particular problem. Right? So that's basically what is called context engineering. Right? It will become clear how it's related to skill. Okay? Now, agent skill. So what is agent skill actually? So now we have agent context. Right? So agent context is all the information the agent has access to. Skill is just another way to provide context to the agent. Okay? So it can be the skills can contain information about some specific workflow, organizational knowledge or specialized knowledge, right? Something that you want to give it to the agent, and the agent have more context about the process. Right? So skills are, and these are like all human readable markdown files, and these are organizing folders. Okay? And the skills, if it is just this markdown, human readable, like simple markdown file, like what's so special about it? There's actually nothing special about it. There are some standards that all these harness builders and all the LLM providers, they have agreed upon, right, that this is a structure, and this is how we're gonna treat the skill structure in a uniform way, right? But there is nothing special about a skill, right? So usually when you look at the skill, you will see something like this, right? This is a skill name here, and then underneath, and this is just a folder. Okay? The folder name of the folder itself is basically the name of the skill. Then you have one mandatory field called skill.md, right? That has the name of the skill, some metadata. We'll go over what kind of metadata it can contain, right? And some instruction, the body, the main instruction that what the skill does, and some constraints and all these kind of things. And then you can have other folders like script, references, and assets, right? And these are some of the most common folders, but you are not limited by just these folders. You can actually create your own folder structure as long as you have the skill.md file. Okay? And these scripts and references and assets, these are optional, and these are loaded on demand, meaning like it's not as soon as you give the skill to the agent, it's not like they're going to load all this information one go to his the context. So skill.md file, right? How the skill.md file looks like. So this is the one file that's mandatory. So you have the name here, you have the description, and then some metadata. Okay, so what kind of metadata you can have? You can have metadata like the author, and then some the version information, or actually this how this skill should be used or invoked, and what kind of tools the skill can so this kind of metadata you can provide in the header section. And this is what we call actually front matter of the skill. And this is actually the most important part of a skill, as we will see. Now, what kind of
Well, can I
information?
just quick question? Like, what it's the
Yeah.
most important because that's what they actually scan, determine what skill to use, correct? You maybe want to talk about why it's the most important.
Yes, I'm gonna just go like just in couple of slides down the line. I mean, we'll just go over it, and then you can if it's not clear, then
All
we can
right,
just talk a
fair
little
enough.
bit
Good.
more about it. So what kind of information can be in the skill? So usually um, some kind of specialized information. So if you're giving a task to the model or to the agent, and the agent is of course going to consult the brain, which is the LLM model. LLM model might not know some organizational knowledge that you have or you follow in your organization. Right? So that means if these are very specific information, specialized information, those information can be in the skill. Right? Repeatable workflows, meaning like you have steps of process in the execution, and these are not just like code block, like if else kind of things, but you have like step one and step two. It kind of like does a little step by step information about how to perform a task or a workflow, and this kind of information can be in the skill. Right? Also, let's say you have how to use something, or like what are the best practices, and you want to share those information to other people that using the agent. And that way you can just give the skill to like it's reusable basically, because it's packaged in a folder. It's very easy to reuse and audit and version and all this kind of things, right? So now what Jeremy was asking when I was saying like this is the most important thing, why this part is the most important thing, right? So this, even though the skills are very easy to read and create, depending upon how you're designing the skill will affect your context, right? Because at the end of the day, the information from the skill will be sent to the LLM. If you remember in the first thing, I was saying two kinds of context: LLM context and the agent context. Skill is a part of the agent context, but now when the agent is doing all these things, The agent needs to figure out what part of the skill needs to be sent because it cannot send all the information. It can, but that's a bad design of the skill, right? So it's very important how you're going to design the skill so that agent is very clear about what to invoke and what to send at what point. Okay? First of all, in the skill, there are like two ways you can invoke a skill. One is the human triggered, and the other one is agent triggered. Right? Human triggered is that the agent is not going to pick it up itself. A human manually need to invoke the skill. Okay. Most of the time, if you guys have used any coding agent, usually we always use slash command, right? Slash command front end design skill. So these are actually like we're manually invoking it. Right? So when should we design a skill that's not agent invoked, right? So let's say if you have a skill that needs to be triggered where the agent does all the prerequisite steps, right? Only then the human verifies manually that all these steps has been already done or performed by the agent. Now I want to do the final step, and I want to manually kind of invoke the skill, right? One thing about the manual skill that none of the information is sent to the LLM beforehand, right? At the time when the user is manually invoking it, only then it's going to the LLM, right? So that means we're managing the context a little bit better because until that time, this agent is not needed. So user is manually invoking it, and only that time we are pushing the information to the LLM. The other one is the agent trigger, right? You These are triggered automatically by the agent, right? So anytime the agent decides that, oh, I need some specific information about, how to do something, and if the description matches, then it will go ahead and pick it up and load into the context by itself. Right? So these are the two invocation. So now the second one is this one, human triggered. Of course, human is going to trigger it. Other one is agent is going to trigger it. That means the agent needs to know based on the description and the name to trigger the correct skill, right? So this is very important from the context engineering or context management point of view, because if the correct skill does not get triggered, that means the agent does not know, missed some information that the skill would have provided, or if the information is too vague, that means it might have picked up the skill even though the skill is not needed, and at that point you're basically polluting the content. Right? Now, because this is the only way, right, for the agent invoked or the model invoked, this is the only way the model is going to pick up a skill. So it's very important to keep the description clear and concise, right? And always you should provide when and what, right? So for example, like, do this, or when something happens, invoke these skills to do this, okay? And if you give very vague description, or you're not very clear about when to do it, agent might falsely trigger the skill or not trigger the skill. So specify the negative scenario. It's also important to kind of sometimes mention when not to trigger the skill, right? So it doesn't falsely, positively identify and then false positive. So in this case, if you can see the example, do not use for, let's say, new logo pricing or contract drafting. So if there are some negative conditions, you want the skill not to fire, then it's better to mention in the skill description. Jeremy, does it answer your question?
It does. It's actually a very good answer. I mean, the one thing that I was like wondering about is how do you basically know and test this? How do you know that it's
Yeah,
like you've
I'm
done
gonna
this?
go.
Okay, got
Yes,
it. Okay,
I'll go. Yeah.
perfect.
So one other thing the skill provides. Okay, so at this point, I want to make something clear, right? So you might ask, okay, the skills are just normal text files or normal, like, markdown files. Why not just put this in a prompt? right? If all we have to do is do the process or like document the process or document the steps, why not just do it in the prompt? So the answer is yes, you can. And that was the primary way that people were doing it. And that's why we had something called like, mega prompt, meaning, the prompt itself contains the process, how to do the process about, in your finance department, let's say, or to do like, your IT department, all these processes and workflows that agent is capable of doing, these are all kind of piled in the system prompt, right? The problem is system prompt is always loaded into the context, right? As soon as the agent boots up, first thing it will do is the first message that you're gonna send to the LLM is gonna send everything that's in there in the system prompt. That means even though you're asking about question X, since your prompt had instruction about X, Y, Z, A, B, C, everything just went to the right. Again, the same problem, right? The agent is gonna be confused, or it, of course, it's you are sending token that's not really needed for solving the specific problem, but we're still sending it. So at the end of the day, the other thing I want to like quickly mention that LLMs are very non-deterministic, meaning everything kind of depends what is the next step or what is the next token prediction. These are all based on probability, right? If you are sending wrong information or if you're sending too much information, then even the agent deviates a little bit in, let's say the very optimum response was response A, right? And response B was less optimum. But since you sent too much information that's not really relevant, that means it was not able to create response A, but it's created something that's a little bit less optimum, response B. So that means like in the first step, there's a little bit of a deviation, right? But the problem is now it will run off of it because one small deviation in the beginning will create a large deviation when the agent run in loops, right? Because agent is never one question in, one question out, or answer out, right? It's a loop process. That means if you make one small mistake in the beginning, that means that mistake will be amplified towards the end, and your agent is not going to get what you are intending it to do. So this is very, very important to manage the context, right? So one difference between
Can we just before you go on, someone just asked a question in the chat.
Mhm.
Someone wanted to know, like you just mentioned loop. They said they've
Yeah,
heard a lot about loop engineering, but they don't really understand or know what it is. Can you maybe spend like 2 minutes just kind of saying what's a loop process or what's a loop like engineering thing because they've heard the
yeah.
term and they just said they don't really know what it means.
So they're actually couple of processes. Okay, so here I'll explain agent loop. What is means like agent loop. So LLM, like I said, LLM is stateless, meaning you send one request, LLM processes, and it gives you an answer. Right? Now, in order for the LLM to do something else, that means you have to ask another question to answer. And so manually, basically, you have to do like a chat interface, back and forth, right? So instead, if so, that's not an agent at that point, right? So agent means that it has its own ability to do action, right? Its own ability to do thinking and like analyzing and do some action by itself. It's not like a chat interface. So the first version that people came up with is what we used to call the React agent, right? React agent is nothing but a loop. So once you send the first request, it's gonna get a response, and that response will be evaluated by the LLM, and it will be feed again. So that's basically the agent loop. Okay? So human is not kind of interacting with the LLM every step of the way, but the agent itself is kind of creating the loop and then communicating with the LLM. At some point, if the agent needs some clarification, then it says, it emits an event that we call it like human in the loop, and it will wait for it. So as
Got
soon as you get
yeah.
the answer, it will continue the loop again. right? So that's
Oh, got it.
basically
And
the
then that's
agent
it.
loop.
Got it. So basically, it's the when you have the human in the loop, that's basically a way that you can check the agent's work. So it's
Yeah,
not making any major changes or making any major decisions without a human actually validating it. So it's just like a second
correct.
set of eyes.
Exactly, exactly. Otherwise, it's a loop. If you don't do it, it'll keep going and going and going. And again, if you don't manage the context better, if it deviates, that means like only thing is producing in a loop is not actually what you want, right? So it's always better to kind of have some checks and balances as the agent is doing the work.
That makes sense.
Okay. So now going back to why not just use a prompt, not why scale, right? So like I said, prompt, there is no mechanism of sending information in pieces. Whatever you put in the prompt, it will just go boom, like everything goes, right? The versus the skills, it has something called progressive disclosure. That was actually the solution of the community, this answer to this mega prompt problem, right? Progressive disclosure is something that it reveals information to the LLM progressively in layers. So the skill.nd file that we actually was showing here, this is the front matter section, like header and the description section. This is the body, right? This is the body of the skill.nd file. Then if you remember here, then we also have the script files, references file, asset files, whatever other folders you have. So the way that it works is in the beginning, when you first get the skill, only thing that the agent is going to send to the LLM is the front matter, name and description. Okay? This is always loaded in the context. And that's why it's always important to make the name and description clear and concise so that you are not overloading the context. Now, the agent decides at one point, I'm going to give a demo on this. Once the agent decides that, okay, I need to invoke this skill because now I have a problem that I have to figure out the answers, and I know this skill has actually given me details about this problem. So I'm going to go and trigger the skill, and then get the body of the skill, right? So body of the skill provides a little bit more information. Okay? But if the let's say the body of the skill provides like step one, step two, but in order for you to do step one, you need to go and reference some documents in the other folders, and that those information are not going to be revealed to the LLM unless and until the point when that step is being done. So that means it's loading the information as it goes, as is needed. That's basically the progressive disclosure, slowly trickling the information to the LLM, right? And it's managing
Gotcha.
the
That makes
context
sense.
better. Yeah. So I'm gonna quickly give a demo here just to show like how it actually works in practice. Okay. I'm gonna actually show it using our platform and our tracing library. So let's say I have an agent here. Okay, this is a data goal agent building platform. So here I have an executive research briefer. This is a custom agent that we have. Right now I have some prompt here. What the agent does, some constraints and some rules and things like that, right? How to do the research, how to generate, what kind of sources it needs to go to. But the important part is it has some skills. Okay? Here, if you look at, I have two skills here. One is the markdown report write and the PDF report write. Right? It just basically gives the instruction. Okay, this is just a demo thing. Give the instruction. If the user is asking about, hey, generate the report in PDF, okay, what formatting it needs to follow and how to generate it in PDF. Okay, so now this is the description. Okay, it's actually showing that if you look at the description, it gives a little bit of a description what it does, but also is
And
showing
just
like
can I just
when.
say, like, I just want to like clarify one thing for our like viewers. Like, so now we're actually demonstrating the data goal skill library and our skill process that exists within our platform. So this is
Yeah,
our own
yeah,
unique take on it that you can apply your own skills and like this process to your tasks within data goal. So we've done a few tweaks that it's like it's a universal thing, but ours is especially formatted for basically our platform, our notebooks, and those type of things. So this is now where we've now transitioned from a general conversation to a skill into actually showing you our skill engine.
Yeah, this is just a skill engine, but the concept that we're talking about is applies to, doesn't matter where you are gonna use your skill. Right? You can use your skill in cloud code or other harnesses. Same principle applies. So now this skill, if you look at the description, I'm mentioning when and what, and also some negative scenario. Do not use for this scenario. Right? Just to give you an example. So this is very clear. That means like the agent knows when to do it, what to do, and when not to do it. Right? And of course, it's the body. Right? So now let's say I'm asking a question to the agent, and I'm going to look into the trace. This is our data goes tracing library. Okay, so we for all our agents, we also capture how the agent is progressing, how it's making call to the LLMs, how it's doing the tool calls, and all this kind of thing. Right. So now this is one of the
But
traces that we're going to look at.
before you go over it, just can you kind of explain because people hear terms like harness, observability, tracing. Can you maybe just give like a 2-minute summary on what those things are and why they matter before you go over this?
So let's just look into the trace of. So when I'm asking a question to an agent, right? Like I was saying, it's a loop, right? So you might be asking one question behind the scene. It's actually doing a lot of things. It's making five calls to the LLM. It making calls like to do the tool calling. It making a call to the scale. So that means like there's a lot of things going on when it's performing the question that you're asking. How do you know? Okay, how do you know what the agent is actually internally doing at every step? Is it performing the correct sequence? Is it performing, the sending the right amount of information? How do you know this? This is where observability of the agents are important. If you guys remember when we used to write APIs, REST API and microservices, right? So we have this observability when the API is making call to the other API calling to the database, other responses are coming, where it's breaking. All these things are like, the agent, like, sorry, the API observability, right? Logs, traces. And same way for agent, also we need to have an observability, inbuilt observability platform to understand how the agent is behaving. And actually, agent observability is way harder than API observability because API is deterministic. LLMs are, you don't know sometimes how it's making the call. Right? So if I look at this agents, one of the traces of this agent, okay? So it has access to some skills, it has some prompt, okay? So this is how it actually made all the calls. Okay? It first made the LLM call, then it invokes some tool calls and make another LLM call, tool calls, right? And ultimately it's giving the answer. So this is basically the whole trace of asking one question. Okay? But now the important part is what is the first message that is sending to the LLM? Okay? If you look at it, there is a system prompt. Okay. And I actually want to highlight something, how it's actually sending the skills. Okay. If you look here in the system prompt, so it says like you have access to a skilled library that provides specialized capabilities and domain knowledge. Okay. And available skills. It has, like I was showing you here, this agent has two skills. One is the Markdown report writer and the PDF report writer. If you see here, it's actually sending that, okay, PDF report write and the Markdown report write, right? It did not send, and only thing it sent is actually the what is the description, the front matter, right? See, it did not send the body. Okay, it did not send anything. It's on a script folder, a reference folder. Only thing it sent in the first go is just the front matter of the skill, right? So in this case, actually, it's gonna be just this part. Okay. Now, this is the first thing that I asked we're sending, and the question was create a PDF report on NVIDIA. Okay. As soon as I'm asking the question, now what's gonna be the LLM's response now? LLM has all this information and it knows that I have a skill that tells me how to generate a PDF report. Okay? At that point, only at that point, it's going to execute a tool to get the body of that skill. Okay, it's actually like it's like because it needs to like these are skills are just files. That means like to get the now the body part of the skill, it has to do a file operation. Right? Only then it's actually went and got the body of the actual skill. So it means in the first LLM call, we did not send the body. Only when the agent or the LLM determined like now I need to know about the PDF report generation. It only loaded the detail of the PDF skill. It did not load the markdown skill, right? So that's basically now what you're doing actually. You are controlling the context that's going to the LLM, right? And now it actually goes back and send only the information. If you look at here now, so this was a tool call and this is the answers to the tool call. So now this information is instruction of exactly what to do. The body of the skill is going to the LLM now. Okay. Now, when LLM is going to read this and then it says like, oh, I have a reference here. I need to go and find something under reference. Then it's going to make another tool call to get the reference. So if you look at here, this is basically the progressive disclosure that we're talking about, right? It's only trying to retrieve the information it needs only at that point of time. Okay.
Gotcha.
Now, yeah. So now, how this is actually very important. So that just means that, okay, first thing it loads the front matter, then the body. That means if you have a very big process that does a lot of things, that means you should not put all this information in the skill file. You need to break it down. I'm just going to give an example. let's say let's say you have a process that you need to do some like a Kubernetes deployment in Azure, AWS, and GCP. Okay, if you put all these steps of all these cloud providers in the body of the skill, that means when they will load the body of the skill, all this information are gone. You might be asking only about Azure, but since you have also put the information about instruction about GCP and AWS, it will pick up those as well. So in this case, what you need to do is you need to layer it out. That means the body is going to say, if you need to find information about Azure, go to reference Azure reference. If you need information about Google, go to GCP reference file. Okay? That means when somebody is asking about Azure, it's going to go to the body, load only that small portion. And then it's going to, oh, I'm asking about Azure, so I need to go load only the Azure reference file. That means it did not load the Google reference file or AWS reference file. Hope that's clear. That's actually one of the very important thing of layering information in a skill, how to organize the folder. Right? So kind of think about this layering, right? The skill.md file, the main MD file, it has step 1, step 2, step 3. Step 1 doesn't do any reference. Step 2 actually have some reference. So only at that point, when it's doing step 2, it will get the reference, this reference file. If this reference file says run this script, then only it's going to go and run, get the information about specific information about the script. Okay? So it's very important to break down your problem in a way that you are doing this layering. At the example that I gave you. Okay? So the other thing is when designing a LLM, oh sorry, a skill, even though we are giving steps that do step 1, step 2, step 3, this is not a coding or like a programming that your steps are very constrained or like very like rigid, right? Do if this, do that. No, because ultimately you want this information to be processed by LLM. LLM is its own brain. Then you need to give the LLM a little bit of a freedom to make its own decision within certain constraint. If you look at the one on the left and one on the right, you can actually see that the one on the left It's just kind of giving like, if else kind of logic, right? At that point, you don't need to write a skill. The skill is not useful because this is like so rigid and so like, fixed. That means you don't need to write a skill for it. Right? In the other one, it's actually giving some context or like constraints, but it's also like giving like the, like a background information how to do it. And then it's giving some freedom how to classify these like, tickets to like P1, P2, or P3. So it's always kind of important to give design the skills in a way that you are not building it too rigid. Okay. So last is the skill evaluation. What Jeremy was asking. How do you know, right? You design the skill, you put it there. How do you know that the skill is performing the way you want? Right?
And how do you
Trigger
know that it's
accuracy.
better? And how do you know that it's better than the baseline?
Yeah, exactly. So first, let's talk about the trigger accuracy, right? How do you know that it's actually triggering the right skill, not the wrong one, or it's not getting triggered when it doesn't need to be triggered, right? So this is actually we need to coming back to the traces, okay? That's when you need to look at the agent traces, right? Because if you remember the agent traces, right, you remember that in the beginning when we're sending the first LLM call, it actually says what it triggered, and it's triggered using a tool call, right? Hey, I need to load this skill to my context now. That means it's going to do a tool call with the file name, right? That's basically the trigger. So now let's say you have an agent and you have a skill A and you want to test it that this under if I am asking question A, then it should be triggered. If I am asking question B, it should not be triggered. Now you can create a process where you are calling the agent. And after the agent is done, you are actually evaluating the traces. And in the traces, you would not, oh, for this question, did the agent call this tool or not? If it did call the tool, that means your skill got triggered. If it did not call the tool, that means your skill did not get triggered. Okay? So you can also use the other question that you're asking, right? How do we actually even need a skill, right? So let's say you have a skill, big skill, right? And you're sending this information, it is getting triggered, but are you actually getting the benefit of the skill or not? Or you're just sending the information just to bloat the context, right? So that means you want to test the agent with the same parameters with or without the skill. Okay. And then whatever response you get, you use another LLM as a judge to determine what is the difference between these two answers, responses that I'm getting. Is it one is better than the other one or not? Right? But you have to define your own criteria, like success criteria, right? That I'm asking the question to the agent and I'm expecting these answers, for example. And you do it one version of the agent with the skill, giving access to the skill, and the one version without giving the skill. Right? And then you get two responses and you compare. If there is not a significant difference in these two responses, that means the skill is not doing much. Right? You're sending all this information, but the skill is not without the skill, the agent is performing fine. That means you don't need the skill. Right? And it's actually very important because I've seen that usually it's very easy to like give 10 skills to the agent. Are they being used or they are just doing nothing and just costing you money, right? So
Because
that's
that's a
a
that's a key point. A lot of times the skill will add to the token cost, and it will call
yeah.
additional tools. It will call do additional things that the base prompt won't. So you have to really make sure that the skill is
Yeah.
actually doing being a value add and is more efficient and or better than the
All right.
baseline.
All right. Exactly. So just think of like human point of view, right? If you are given a task and you have provided like 10 books of unrelated stuff, and you still have to look into them to find out like if anything that useful in these books, but the books are not useful. That means what you're doing is you are just spending your energy reading through going through something that's actually not going to help you, right? Is exactly the same thing. The third one is like evaluate outcomes, not path, meaning you have designed your skills. you have these references and skills, right? You have design, but sometimes since the LLM is sometimes have a unique way of solving problems, it might not necessarily just say like even though it had to go to the reference, like for example, like step two, but it actually went in step three, but it still actually found the answers, right? It did not follow the path you were expecting, but still found the answer to your question. So that's fine. So you can evaluate the outcome, not the path. But it's very important to kind of also understand that you have a skill. So going back a little bit, so skills are a way for you to give more context to the LLM. You are giving more context to the LLM because the LLM does not have the information needed to solve a particular problem. Maybe today, right? As the LLMs are getting trained more and more, at that point, it might actually have that information already. Okay, that means you don't need the skill to provide the extra information anymore. Okay? So that means it's very important to keep revising your skills. Skills are not just like one time and then done. You it's like a living and breathing thing. You need to kind of go over, see like if there are like duplicate information in multiple skills, or these skills are even being used, even needed. So you always need to go and kind of look into and kind of revise the skills as as you go along, because it's very easy to create something. A lot of people are modifying it, a lot of people are adding information, and at the end of the day, the agent is not useful any longer. At that point, you're just confusing the agent. Okay? So um, that's all I had for today for skills. I'm happy to take any, like if anybody has any questions.
Let me see. We just have one question. They basically said, like, how do you transfer skills from one LLM to another?
How do you transfer one skill from one LLM to another?
So basically, they're saying, I just reading into it, it's like I'm guessing that they've done a skill, let's say on Claude, and they want to move that skill over to us, or they want to move it over to ChatGPT.
It's
I
a
believe the answer is just copy and paste, more or less, the actual
or you
skill.
just download or you just
Yeah,
download the markdown file, right? And if it is a folder, it should give you an option to download the folder as a zip file and you upload it again, because these at the end of the day, these are just a file sitting in a folder.
correct.
Yeah,
So the answer is basically it's the same basic skill. They're all pretty much movable from one platform to the other. They've all adopted the same
they are
basic
portable.
formats. Yes.
Correct, they're portable.
So you
Exactly.
don't feel like locked in because you built your skills on Claude. You can take those
Yeah,
skills and move them anywhere else, is the answer.
exactly. And the point that I was making, that the agents are, it's not standard, but it's a agreed upon standard of like ChatGPT follows it, Claude follows it, any other harness that you are using, right? They follow it. If you're designing your own harness, you should like you should need to implement something how to process the skill, and you need to follow that guideline, right?
Okay,
It's kind of like a
we have one more question. Also, what is a harness? They said that you've used that term several times. Could you define what a harness is?
yes. So I said here, for example, okay, in this slide. So the agent. So we have two contexts: LLM context, limited; agent context, lot of information, right? Somebody needs to decide in the middle, the agent, right? The agent needs to decide which information to assemble in each step of the way and what to send to the LLM, right? Now the agent harness, it just sits on the bottom of the agent. It just provides like more like support for it to assemble context. So it's just a bunch of like tools and like procedures and how to process the skill, how to retrieve the memory, how to retrieve the make the tool calls. All these are actually done by the harness. Harness are just a way so that the agent can send the right context to the LLM in one word. So if now if you think like all the problem that we have is basically assembling the context engineering. And agent harness is a component that help assemble the context, engineer the context so that they can send the right information to the LLM, the right.
So the question that we just got is the harness part of the skill, or does it sit below the skill at the actual like
So
holistic
harness is
level?
not part of the C. Remember, skills are just, right? Agent harness would know how to process the skill. So since it's just a bunch of files in a folder, how somebody needs to decide like, oh, this is the description, this is the body. This I need to send this description at this point. I need to send the body at this point. I need to load the reference. That part isn't harness is going to do. Okay, skills are just a this information sitting. Isn't harness is processing the skills.
Got it. I think that
Yeah,
makes sense to me. Let's see if we have any other additional questions.
yeah. And feel free to send questions offline.
Yeah, you can like
Reach
reach
us
us.
in LinkedIn or yeah, doesn't matter. So we'll be happy to get back.
Correct. And we're going to send everyone who came the recording of this along with this deck. And if you have any questions, just feel free to respond to that email. We're also going to put Jyotish and my own personal email and our LinkedIn on that, so you can reach out to both of us either via email or via LinkedIn, whichever is your preferred way. If you have additional questions or you want a demo of this, or you want to just basically see how we can like help you like build a skill out yourself.
Yeah, for sure. Yeah.
Okay, cool. So last call for questions. You guys have any more? Let me just check. Okay, cool. It looks like we are good with questions. Thanks everyone for joining.
Thank you
Thank you,
so much.
Jyotish, for like
Yep. Thank
hosting and
you.
doing this amazing demo. And be on the lookout probably tomorrow for us to basically send you this deck and send you this recording. Thanks for joining. And we're going to be looking to do office hours once a week starting next week. So if you want to learn more about Data Goal, or if you have questions about our platform, or if you're already an existing user and you just came on to kind of see what we were talking about, that would be a great time to come and just ask questions and learn more about what we have to offer as we roll out like V3 of our platform in the coming weeks.
Awesome. Yeah. Thank you, everyone. Yep.
Bye.